Such disease is anthrax, caused by a bacteria called Bacillus anthracis. People get infected with anthrax when the spores of Bacillus anthracis enter the body. These spores can find their way inside our body when an infected animal bites or scratches our skin, or if we eat food or drink water contaminated with spores. Once inside our body, spores get activated and develop into anthrax bacteria. So, Melissa Finley, veterinarian, and Brian Carson, senior member of technical staff at Sandia National Labs in the USA, developed a portable diagnostic device for testing anthrax. This device has various components. We take a swab or a saliva sample from a patient and insert the swab in a detection chamber where there is a growth medium that is so specific that only Bacillus anthracis can grow in it. After a while, a magnet is used to release the valve so that the bacterial sample can move to an assay strip. If the sample contains Bacillus anthracis, a colored line will appear on the strip in a few hours. This will conclude that the patient has been infected with Bacillus anthracis and needs immediate treatment. Let's meet Melissa Finley and Brian Carson at Sandia National Labs, demonstrating how the portable anthrax diagnostic kit works.
I work for International Biological Threat Reduction, and our responsibility is to engage laboratories overseas to try to minimize or reduce the biological threat posed by specific pathogens. So we decided that we would try to brainstorm and come up with an application or a tool that could be deployable to support our mission of enhancing safety and security globally.
The critical aspect of this device that hasn't been done before is that it's integrating everything. So our test is the frontline field test, everything in one device. Somebody can walk up, pull one of these out of the bag, take their swab, do the test, and know whether they need to raise an alarm.
A swab introduces the sample to the detection chamber, which is then sealed. The growth medium is specifically tailored for Bacillus anthracis. After a specified amount of time, a magnet is used to release the valve so the microcultured material can then flow onto a lateral flow assay strip, similar to strips used in pregnancy tests, but this one only reads Bacillus anthracis. The selective growth medium and the lateral flow assay selectivity allows for biodetection in the field that rivals laboratory analysis.
This device also can detect a very, very minute quantity of the Bacillus anthracis spores. We've been able to detect just 100 spores, and similar assays need 1 million or 10 million spores to be able to detect.
Scientists at Sandia National Laboratories put in a lot of thought and efforts in developing this diagnostic device. It has a simple design so that people and doctors with not much experience can operate it. The testing kit can survive high temperatures, requires no refrigeration storage, and is inexpensive. But after using the test, we can't just throw it away. The portable test contains a bacteria swab, and we cannot risk having anyone getting infected by touching it. So scientists built a magnetically operated sterilization valve which will make the device self-sterilize or self-clean. That means the swabs wouldn't be able to spread infections. But what about the infections that have spread already? How do we cure them? Especially the ones that are life-threatening and affect hundreds of thousands of people each year. One such disease is the well-known acquired immunodeficiency syndrome, or AIDS. AIDS is caused by human immunodeficiency virus, or HIV, and they weaken our immune system. The virus likes to live in bodily fluids like blood. So the transfer of an HIV-contaminated blood in a healthy person causes the virus to enter their body and cause infection. Once HIV enters the body, it targets and kills T cells of the immune system. T cells are our soldiers and defend our body against pathogens or harmful microorganisms. The HIV enters the T cells and inserts its DNA into the T cell's DNA. While many of the T cells die, some of them will survive but instead produce more HIV. Over the course of time, the level of T cells decreases and causes AIDS, a condition of weakened immune system that makes a person susceptible to infections and cancers. The available treatment helps to keep the level of HIV low, but there is no definite cure. So the patients have to take medicines for the rest of their life. Sad but true. But Jeff Galvin, CEO and founder, and David Poza, Chief Science Officer at American Gene Technologies in the USA, thought, if the virus can mess with the DNA of T cells, why can't we do the same?